Alright, in this video we're going to do the sum and difference identities, and we're also going to do the double angle identities and the half angle identities. So there's going to be 3 total, and this is going to be for 2 days worth of class. Okay, so the first one is going to be the cosine of a sum or difference. And the proof for this identity is going to be on page 463 and 464 if you'd like to look in your book and see how we derive this identity. Basically, it says that the cosine of x plus or minus y is equal to the cosine of x, the cosine of y, minus plus the sine of x, the sine of y. So please make sure that you guys see that this is the sign change, okay? Pay close attention to that. So note the sign change. Okay, so if you're adding your 2 angles, you're going to be subtracting over here, and if you're subtracting your 2 angles, you're going to be adding in the identity. Okay, so we use this identity when we're asked to find the exact value of angles that are not on our unit circle. Okay, so other like the cosine of 15, which is our first example. 15 degrees is not one of our angles that we have memorized from our unit circle. But what we do know is we know that 15 is the same as saying 45 minus 30. Okay? So although we can't find the cosine of 15 degrees, we can find the cosine of 45 degrees minus 30 degrees. Okay, so in order to do this, we are going to use our cosine of a sum or difference. In this case, it's a difference. So we'll take cosine of 45 degrees times the cosine of 30 degrees, and then add that to the sine of 45, sine of 30. So in this problem, our x is like the 45, and our y is like the 30 degrees. Okay, so we have the cosine of 45, cosine of 30, plus the sine of 45, sine of 30. All right, from our unit circle, we know the cosine of 45 degrees is the square root of 2 over 2. And we know that the cosine of 30 degrees is the square root of 3 over 2. And then we are adding this to the sine of 45, which is the square root of 2 over 2. Times the sine of 30, which is 1/2. So in this case, we are going to get the square root of 6 over 4 plus the square root of 2 over 4, which when we simplify is going to be equal to the square root of 2, the square root of 6 plus the square root of 2 all over 4. This would be our final answer. In this next example, it's very similar. You are asked to find the exact value of the cosine of 75 degrees. Okay, take a minute and try this problem now by yourself. So go ahead and pause this and try it by yourself. When you complete with the problem, you should get your answer to be the square root of 6 minus the square root of 2 all over 4. This should be your answer. Be sure to try this problem by yourself first. Alright, the next identity is the sign of a sum and difference, okay? The proof for this is on page 465 if you'd like to go look at it. And basically what this one says is the sine of x plus or minus y is equivalent to the sine of x times the cosine of y plus or minus the cosine of x, the sine of y. Note in this one that our signs stay the same. Okay, so if we're adding our 2 angles, we're going to be adding in our solution. If we're subtracting our 2 angles, we're going to be subtracting in our solution. Okay, so this time we're asked to find the sine of 15 degrees. So basically, it's very similar to the last example we did. We are just going to take the sine of 45 degrees minus 30 degrees. All right, plugging it into our identity, we have the sine of 45 cosine of 30 minus the cosine of 45 the sine of 30. Okay. From our unit circle, we know that the sine of 45 degrees is the square root of 2 over 2. We know that the cosine of 30 degrees is the square root of 3 over 2. The cosine of 45, square root of 2 over 2. And the sine of 30 is 1/2. Okay, so putting this together, square root of 6 over 4 minus the square root of 2 over 4. And when we simplify that, square root of 6 minus the square root of 2 all over 4. Okay. Okay, our next identity is the tangent of a sum or difference. The tangent identity, the proof for this is on page 467, and it basically says the tangent of x plus or minus y is equivalent to the tangent of x plus or minus the tangent of y over 1 minus plus the tangent of x tangent of y. Okay, so this is our identity, and let's say that you are given the example tangent of 5 pi over 12. What you're going to do is you're going to find two angles that add up to 5 pi over 12. In this case, we can say, all right, the tangent of 3 pi over 12 plus 2 pi over 12. When we simplify those two measurements, we're going to get the tangent of pi over 4 plus pi over 6. These are two angle measures that we have and know on our unit circle. Okay, so plugging this in to our identity, we are looking at the tangent of pi over 4 plus the tangent of pi over 6 over 1 minus the tangent pi over 4 times the tangent pi over 6. Okay, so using your unit circle, or what we know about the tangent of different angles, we know that the tangent of pi over 4 is going to be 1, plus the tangent of pi over 6 is the square root of 3 over 3, and that's all divided by 1 minus the tangent of pi over 4, which is 1, times the tangent of pi over 6, which is square root of 3 over 3. Okay, so right now we have kind of a complex fraction going on here. So what I'm going to do is I'm going to multiply the top and the bottom fractions both by 3. That's going to eliminate this complex fraction, and that will give us 3 plus the square root of 3 over 3 minus the square root of 3. Okay? Okay, now what happens is we have a radical on the denominator, so we need to get rid of that. So we're going to multiply by the conjugate, which would be 3 plus the square root of 3 over 3 plus the square root of 3. Okay, when we multiply that together, on the top we end up with 9 plus 6 square roots of 3 plus 3 over, and on our denominator we get 9 minus 3. Okay, when we simplify that, we are going to get 12 plus 6 root 3 over 6, which again will simplify to 2 plus the square root of 3. So our answer ends up being 2 plus the square root of 3. Now, some of you might look at this and see that that is a lot of work to go through the tangent of a sum or difference. Now, keep in mind that there is a simpler way to do this problem. Okay? If you remember your identities, your quotient identity, we know that tangent of x is equivalent to the sine of x over cosine of x. Okay? So that means that the tangent of x plus or minus y is going to be equivalent to the sine of x plus or minus y over the cosine of x plus or minus y. So if you think about this, it might be a little bit easier to solve this problem rather than going through the tangent of a sum or difference. Okay? All right, the multi-angle identities. This is going to be from section 5.4 in your book. Okay, the first one that we're going to talk about is the double angle identities. And as you can see on this printout, we have one and only one for the sine of 2x. This is a really quick little proof of how you derive the sine of 2x, and we use the sum of the sine identity that we just talked about. So basically what ends up happening is the sine of 2u in this case is equal to 2 times the sine of u times the cosine of u. Okay, this is a very important identity that you should memorize. When you can use the sine of a double angle, it's good because there's only one option. Now, when you get to the cosine of a double angle, so the cosine of 2u, using our sum and difference identities, we see that we get the cosine of 2u minus the sine of 2u squared. Both are squared, sorry. All right, so the problem with this is you can use your Pythagorean identity to kind of change this identity in a couple different ways. So the cosine of 2u ends up having 3 possibilities. So the sine of 2u has 1, the cosine of 2u has all 3 of these as options. Okay, so that's what kind of is a little bit confusing about it. So these again are just derived by using Pythagorean's identities, by substituting, you know, sine squared equals 1 minus cosine squared of x, that kind of thing. Okay? So we're going to do one of these examples here on this sheet. We're going to do the first one where it says to solve for the sine of 2x equals cosine of x. Okay? Our answer needs to be in the interval from 0 to 2 pi. Focus. Okay, so again, the problem is the sine of 2x equals the cosine of 2x on the interval 0 to 2 pi. So what we need to do is, first of all, rewrite this problem so everything's on one side. Remember, we cannot divide by the cosine of x to solve this. So let's rewrite this as the sine of 2x minus the cosine of x equals 0. Now, this is good because the sine of 2x, we only have one option to plug in for that. So we can go ahead and plug in the 2 sine of x, cosine of x, minus the cosine of x equals 0. Okay, from this step we're going to go ahead and factor out a cosine of x. We're left with 2 sine of x minus 1 equals 0. Okay, using the zero product property, we can know that cosine of x equals 0 or 2 sine of x minus 1 equals 0. All right. From what we know on our unit circle, the cosine of x is going to equal 0 at pi over 2 and 3 pi over 2. Here, if we solve this for the sine of x equals 1/2. And on our unit circle, that is true at pi over 6 and 5 pi over 6. So our answer to this problem is going to be pi over 6, pi over 2, 5 pi over 6, and 3 pi over 2. Okay. All right, the second example on this page is solve sine of 2x plus sine of 4x equals 0 on the interval from 0 to 2 pi. Okay, I'm going to let you guys do this problem by yourself. I do want to give you one hint to start you off. And your first step should be to take the sine of 2x plus the sine of 2 times 2x equals 0. So you're going to be using the double angle identity a couple different times in this problem. So just be careful. Your first step is to do the sine of 2 times 2x here. Okay? When you're all finished, you're going to get many answers for this problem. You're going to get x equals 0, pi over 3, pi over 2, 2 pi over 3, pi, 4 pi over 3, 3 pi over 2, and 5 pi over 3. Okay, so make sure that you try this problem and bring it in tomorrow. Okay. All right, the last identity for this video is the half angle identity. Okay, and I'm going to give it a minute. All right, your half angle identity, there are 3 of them again. And basically what you end up with is your sine of your angle divided by 2 equals plus or minus the square root of 1 minus the cosine of u over 2. Your cosine of u over 2 is equal to plus or minus the square root of 1 plus cosine of u over 2. And the tangent of u over 2 is equivalent to plus or minus 1 minus cosine of u over 1 plus cosine of u, which is equivalent to 1 minus cosine of u over sine of u, which is also equivalent to the sine of u over 1 plus cosine of u. Okay? So that's kind of a lot to comprehend there, but make sure that you understand that these identities do exist. Okay? Now, in example 7, you're asked to solve for the sine squared of x equals 2 sine squared of x over 2. This problem you were just solving for x. So this is kind of a lengthy problem, but you can try this one on your own. You are going to get x equals pi over 2 plus pi k, and x equals 2 pi k. And remember that k is an element of the integers. Okay, so you can try that one on your own. But I would like to go through example 8. In example 8, it says, use the half angle identity to find an exact value without a calculator for the sine of pi over 8. So what we are going to do is we are going to rewrite the sine of pi over 8 because we don't know that angle. And we're going to rewrite it as the sine of pi over 4 divided by 2. Okay, so the sine of pi over 4 divided by 2, we're going to use our half angle identity for sine. And what that is equal to is positive or negative square root of 1 minus the cosine of pi over 4 all over 2. Okay, so that is equivalent to plus or minus the square root of 1 minus the square root of 2 over 2 all over 2. Okay, just like we did before, we need to get rid of this complex fraction here, so I'm going to multiply the top and the bottom by 2. So when we do that, we get the square root of 2 plus the square root of 2 all over 4. And when we simplify that, we end up getting the square root of 2 plus the square root of 2 all over 2. Now, if you notice in my answer here, I took off that plus or minus. The reason why it is just going to be a positive answer refers back to our original angle, pi over 8. Pi over 8 is in the first quadrant, and in the first quadrant, sine is positive. Therefore, our answer to this problem needs to be positive. Okay? All right, so this is your video for sum and difference identities and for your multi-angle identities. Tomorrow in class we're going to do the sum and difference, and then on Wednesday we are going to do our double angle identities. Okay, so just be prepared for that. Tomorrow on Tuesday we are doing sum and difference, and on Wednesday we are doing our multi-angle identities.